Hello, I'm the Awesome Tutor, and today we're going to be looking at limestone. Now, limestone is obviously a rock, but what type of rock? It is a sedimentary rock, which means that it's made of the remains of dead animals or plants compressed from over millions of years. What is in limestone's composition? Well, limestone is mainly made of calcium carbonate, CaCO3. Do not get this confused. Limestone is not calcium carbonate, but it is mainly made up of it. We extract limestone mainly from quarries by digging it up or by using explosive charges to dislodge the limestone from the rock face. Now, the uses of limestone, well, its main use is as a building material. Limestone is very good as a building material and is used a lot. But another use, you could say, is used to make cement. So we get the limestone from the quarries and it's usually sent all the way to cement factories. Now, what are the advantages and disadvantages of limestone quarrying? Well, the main advantage is it provides lots of jobs, employment, as you'll have people quarrying there and people driving the trucks or lorries containing the limestone. Another advantage is obviously you get the building material itself, useful product, because limestone is a building material and so you're getting that when you're quarrying it. A disadvantage, however, is, well, you've got many disadvantages. You're quarrying limestone. Okay, you're taking them in trucks, which obviously pollute the air as well as the factories. So you've got air pollution. What else have you got? You have got the destruction of wildlife habitat. Imagine you're quarrying in a habitat destruction. But also the loud noises from the explosive charges. And the loud noises, what do? They drive animals away. You could also talk about dust from the quarries, and yeah. Let us move on to cement and concrete. So as I said, limestone is usually used to make cement. And how does this process work? Well, it's mixed with clay and heated, and that gives us cement. How do we make concrete? Well, first of all, what do we use concrete for? It's a very good building material. Why is it a very good building material? Because it is very resistant to forces which tend to pull it or squash it or crush it. So we use cement and sand and water and crushed rock to make concrete. We mix these items together and a slow chemical reaction will take place. The crushed rock is usually referred to as aggregate. Now, making mortar. Mortar, we use cement and sand and water. Now, what is this picture I have drawn for you here? We've got a concrete block, and what do we have in it? Iron or steel rods. And what do these do? These make the concrete stronger. And we call this reinforced concrete. We reinforced it with iron bars or steel bars. Next. Okay, so here we have the limestone cycle, the limestone reaction cycle. So first we start off with limestone or CaCO3. The S here means it's solid. How do we get from limestone to quicklime? Well, limestone goes through a process called thermal decomposition, and you need to know this. Thermal decomposition is an endothermic reaction, which means the reaction takes in heat in order to form the products. Let me give you the equation. So calcium carbonate reacts, thermally decomposes to give you calcium oxide and carbon dioxide, which is why I've drawn an extra arrow here, because carbon dioxide is given off. And obviously you can talk about the issues with that, global warming and blah 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 blah. So then we get quicklime or calcium oxide. Now calcium oxide is usually used for cement making. And as I said before, limestone is a building material. So how do you get from quicklime now to slaked lime, calcium hydroxide? What we do is we add water. And by adding this water, so calcium oxide plus H2O is going to give us calcium hydroxide. But we only add a little bit of water, because if we add too much, it's going to become calcium hydroxide solution, which we will talk about later. So slaked lime or calcium hydroxide is usually used for neutralizing fields, or such as fields which have acidic soils. Now how do we get from slaked lime, calcium hydroxide, to calcium hydroxide solution, also referred to as lime water? We add even more water. Now remember, if we add more water, it becomes solution. And that's what the aqueous means. Now calcium hydroxide solution or lime water is commonly used as a test for carbon dioxide. Remember that experiment you do in school where you have a test tube of lime water and you blow into it with a straw? You blow carbon dioxide into it and the lime water turns not cloudy, not milky, it turns white. White is what happens. It is not cloudy, it does not turn milky. These are not good chemical terms. So, how do we get from lime water to limestone? Well, limestone or calcium carbonate is actually white, which is that white substance that forms when you put carbon dioxide into it. So what do? We add carbon dioxide. That's how we get from lime water to limestone. So calcium hydroxide solution plus carbon dioxide, so reacts with it, gives you calcium carbonate and water. And that's why I've drawn this extra arrow, because water is also produced. And then you're back where you started with limestone. And now we're going to move on to the rotary kiln. So what happens in the rotary kiln? Well, I can tell you that from this beautiful diagram, the first thing you should know is that the kiln rotates. It rotates round and round and round and round. And why do we have a rotating lime kiln? Because it helps the limestone mix thoroughly with the hot air. And this helps it thermally decompose completely. So here we add in hot air. And the hot air comes out here, but it has gone through a reaction. So now it's not air and oxygen from the air, it's air and carbon dioxide. Because remember, this reaction is thermal decomposition. And in thermal decomposition, we get quicklime, which is formed here, calcium oxide, quicklime. And obviously we add the limestone here. And the hot air is to give the particles enough energy so that they're above activation energy in order to go through the reaction. Thermal decomposition requires heat because it is endothermic. Yeah, that's actually it. Now, sometimes it's not used in a rotary kiln, sometimes it's just used in a normal lime kiln, in which case the kiln does not rotate, and sometimes also methane is added instead of hot air, because methane is a fuel, and so it burns to release heat energy, and that's where you get your heat from instead of the hot air. Next. Now the last part we need to look at is carbonate reactions. There are two main reactions: thermal decomposition and reactions with acids. In thermal decomposition, we've already gone over this several times. It produces an oxide and carbon dioxide. If we have a metal carbonate, it thermally decomposes to give you a metal oxide and carbon dioxide. This is the general word equation. Here we have some examples. Zinc carbonate. It will thermally decompose to give you zinc oxide. Here's our metal. Here's our oxide part. And obviously, carbon dioxide is given off. Sodium carbonate thermally decomposes to give you sodium oxide. It's straightforward. Metal, then the oxide. So, reactions with acids. Now, reactions with acids makes limestone a problem. So, any building made of limestone, if it comes into contact with an acid, it will corrode. And how is this a problem? Because with gases such as sulfur dioxide and nitrogen oxides, which react with water in the atmosphere to produce acid rain. And acid rain is obviously acidic. And so if the rain comes in contact with the limestone building, it will corrode the building, and obviously this is a problem. So the general equation for reactions with acids is metal carbonate reacts with an acid to give you a metal salt and carbon dioxide and water. You need to learn this. So, example, calcium carbonate reacts with hydrochloric acid to give you calcium. So the name goes first, calcium chloride. Hydrochloric acid, when reacted with something else, gives you a chloride. Hydrochloric acid, chloride. Magnesium carbonate reacts with an acid to give you magnesium sulfate and obviously carbon dioxide and water. Now, what produces a sulfate? That is sulfuric acid. You need to learn this. Now, sulfuric acid has a formula of H2SO4. And you need to learn this, as well as the formula for hydrochloric acid, especially the higher tier students. Now for our last example, something carbonate reacts with nitric acid to give you lithium nitrate. So, nitric acid gives you nitrates. And obviously you've got carbon dioxide and water. Lithium nitrate, so it's going to be lithium carbonate that thermally decomposed. As you can see, it is basically straightforward. As long as you learn the general equation, you'll be fine. And nitric acid, the formula for that is HNO3. Again, you need to learn these. This has been the Awesome Tutor. Bye bye.